show by the principle of mathematical induction that for all n belonging to the set of natural numbers, the following is true. Let us begin. So first thing first, what we'll do, we'll convert the given equation into a statement. So for this, we will suppose that let Pn be the statement. P of n be the statement, such that we can now rewrite our mathematical statement as P of n such that 1 squared plus 2 squared, 3 squared plus 5 squared added to the rest of the terms and the final term, that is 2n minus 1 whole squared. This is going to be given by 1 over 3 times n times 4 times n squared minus 1. Okay, so this is statement number 1. Now, the goal of this particular problem is that we need to verify that this equation that has been given to us, or you can say this statement that has been provided to us, we need to verify that it is true for any natural number that we pick up. We don't have to prove this particular expression. We have to prove that it is true for all natural numbers. So how shall we do that? So first we are going to choose the natural number 1. So for n equals to 1, that means we want to find out the statement P of 1. P of 1 means we only have to consider the first term, which is 1 squared. This is going to be equals to, now, or coming to the right hand side, we're going to replace this n with 1, such that we have 1 over 3 times 1 multiplied to 4 times 1 squared is simply 4 minus 1. 1 square gives us 1. This is going to be equals to, now 4 minus 1, that's 3, and we have a division by 3, so that also gives us 1. So here we have shown there that the statement P of n, this original statement given by 1, this statement is true. This statement is true for n equals to 1. So we have shown here that it is valid for n equals to 1. Now, to show that it is also true for other natural numbers, so we will make an assumption here. We will suppose that let n be equals to m. That means we are saying that, let's say, n P of m, this statement is also true. This statement is also true, which means that we can rewrite now statement number 1 as P of m such that we have 1 squared plus 3 squared plus 5 squared. So this sum goes all the way up to the last term. Now instead of 2n minus 1, which we have in the original statement, we're going to replace the n with m. We get 2m minus 1 whole squared. Similarly, on the right hand side, we get 1 over 3 times m multiplied to 4 times m squared minus 1. Fine. We're going to name this as statement number 2. Now what we'll do, since we are assuming that P of m is a true statement, we will show that it is also true for the next consecutive integer. So after m, we have m plus 1. So we will try to find out, we'll try to show that P of m plus 1, this is true as well. So how do we show that P of m plus 1 is true? We need to show that P of m plus 1, the statement is such that we have 1 squared plus 3 squared plus 5 squared going all the way up to 2m minus 1 whole squared. And we also have to consider the next term. The next term, it will be simply replace this m value with m plus 1 in 2m minus 1 whole squared. So that's going to give us 2m plus 1 whole squared. This is going to be equals to 1 over 3 times m, so replacing m with m plus 1, multiplied to, we have 4 times m plus 1 whole squared minus 1. So this is what we need to prove. So what we will do, we'll start from the left hand side. So that this particular expression of Pm plus 1. Now, on the left hand side will be equals to, so we have 1 squared plus 3 squared plus 5 squared going all the way up to, we have 2m minus 1 whole squared added to 2m plus 1 whole squared. Now luckily for us, if we consider the first term added up to the second last term, 2m minus 1 whole squared, we can replace it with 1 over 3 times m times 4m squared minus 1. That's because we have already considered that Pm is a true statement. So let's replace this. We have 1 over 3 times m times 4 times m squared minus 1 added to 2m plus 1 whole squared. Now we'll be combining these two terms. Now we will be adding the two terms. Now before doing that, here we have 4m squared minus 1. Now 4m squared minus 1 can be also expressed as 2 times m whole squared minus 1 squared, which gives us the difference of two terms. That means we have squared up the difference of two terms, which means we have 2m minus 1 multiplied to 2 times m plus 1. Now we'll be using this such that we get 1 over 3 multiplied to m. Now 4m squared minus 1 can be expressed as 2m minus 1 multiplied to 2 times m plus 1 added to, so here we have 2m plus 1 whole squared. Now again we have two terms. Now from each of the terms we can factor out 2m plus 1. So we have 2m plus 1. Now what we'll do, we'll also factor out 1 over 3 from each of the terms such that we have 2m plus 1 over 3 as the common factor, and this is going to get now multiplied to m times so 2m minus 1 added to, now we have already factored out 2m plus 1, so we'll be left with 3 times 2m plus 1. Okay, now let's further simplify this. This is going to give us 2m plus 1 a whole divided by 3, and when we simplify this, this is now going to give us 2m squared plus 5m plus 3. Okay, now this is a simple quadratic expression. We can factorize it, and that's going to give us 2m plus 1 over 3. The factors are going to be m plus 1 multiplied to 2 times m plus 3. Okay, now what we'll do, we will keep m plus 1 over 3 intact. M plus 1 divided by 3, this is going to be kept intact. Now 2m plus 1 multiplied to 2m plus 3, we're going to multiply both of them, and that's going to give us 4 times m squared plus 8m added to 3. Fine, we're almost done. We'll do a few manipulations before getting into the final result. So we have m plus 1 over 3 that will be multiplied to, so we have 4m squared plus 8m plus 3, but we're going to rewrite the 3 as 4 minus 1. Fine, now we are almost there. Now we have 1 over 3 multiplied to m plus 1 multiplied to, now 4m squared plus 8m plus 4, that can be also expressed as 4 multiplied to m plus 1 whole squared minus 1. And this is exactly the expression that we needed. So this is the right hand side. So we can verify that. So we needed 1 over 3 times m plus 1 multiplied to 4 times m plus 1 whole squared minus 1. Okay, so we have been able to show that since the left hand side equals the right hand side, this implies that the statement that we have considered, p of m plus 1, so p of m plus 1, this is a true statement. So this is a true statement, and since it's a true statement, now we can generalize this and say that hence the original statement p of n, that the original statement p of n is going to be a true statement. This is true for all values of n belonging to the set of natural numbers. So we have successfully proved our problem by using the principle of mathematical induction. That means that the given statement is true for all values of n belonging to the set of natural numbers.